Section 6 is the last section in our chapter on factoring. And basically what we're doing here is it's not a new factoring method as much as they'll give you a complex polynomial. And sometimes you have to factor it one way, then factor it another way. And in trying to figure out what do I do, how to explain this to people, said, okay, here's the order I'd try to go through the things in. So first of all, I start with step number 1, no matter what it is, see if you can find a greatest common factor. If you can find a greatest common factor, pull it out to make the polynomial more simple, then these next steps will be easier. The second step, if you have a binomial, so after trying greatest common factor, if you have something that has only 2 terms or 2 sections, check and see if it fits this difference of squares. Is this first term something that is squared? Is the second term something that's squared? And is there a minus in between it? It has to be the minus. If you did greatest common factor and you don't have a binomial, skip that step. If you have a trinomial, you could look also for something squared to get this, something squared to get that. If so, maybe it fits this perfect square section. If it doesn't, then you can factor it into 2 binomials. So our answer is just going to be one binomial, one thing with a plus or a minus, times something else with a plus or a minus. And if you don't like that perfect square section, this here, you could just factor it this way as well. Last thing is if you have a polynomial with 4 or more terms, it's a good candidate for factor by grouping that hopefully you remember from section 2, so check that out. So first thing is you need to know when to stop. Have you finished a problem? That's where I can think back to high school, and I vividly remember thinking I totally rocked a test, and I got it back, and I'd stopped too soon. I'm still mad about it, and that's been more than 5 years. Okay, so this thing here, is this factored completely? So we had an original polynomial, we'll say. We pulled out this greatest common factor. Are we done? So looking at this here, no, because 6 and 4 are both even. That means we still can pull something out. They're both divisible by something. So to do that, I'm just going to copy down my 3x squared. I already pulled that out. We could divide my 6 and my 4 both by 2. So I'm going to say I'm going to pull another 2 out of that stuff in parentheses. And now what's left? If I have this 6x, I divide it by 2, 3x is left. And I have this minus 4 divided by 2. That gives me a 2 left. All right, so now I've kind of successfully factored this thing into those 2. But now to write it as a simplified thing in the end, I can combine my 3 and my 2. So 3 times 2 is 6. Then I have an x squared. And then we just write what's left inside the parentheses. So now, because we can't find a greatest common factor, can't divide by any number other than 1, can't pull an x out of both terms, we know we are done. Okay, example 2. Is it factored completely? Well, if we go back and kind of look at those steps up on the top, could we have a greatest common factor? Can we pull an x or a number out of both of those? Nope. Can't pull an x or a number out of both of those, so we're good there. The next step is to go down to number 2. It's a binomial. So do we have a difference of squares? This would be x squared. This would be 1 squared, but it's not a difference. It's not a minus sign there, so we can't do anything with the first polynomial. Second thing, we have the difference, and that's 2 squared, but we don't have an x squared. So neither one fits difference of squares. So is it factored completely? A resounding yes. Nice part about that is, I should phrase that in the other way. Oh, the sad part is we can't factor it more. But okay, on to the next page. So this one here, I see the trinomial part right away. So it might be tempting, kind of if you're rocking it old school, to go and say, ooh, I'm going to make this a binomial times a binomial, and they both have to be plus, and you could just kind of hit the ground running like a crazy fool. What you might want to do first, though, to make life easier, is do the greatest common factor. So step 1, greatest common factor. We have 3 even numbers there, so I could divide by 2 for sure. I can't divide them all by 5. I can't divide them all by 10. So I'm going to go and pull a 2 out of each of those 3 clumps. So let's see. Maybe I'll switch to black. If I pull a 2 out, 10x squared divided by 2 gives me 5x squared. Then I have a plus 48x divided by 2 gives me plus 24x. And a positive 32 divided by 2 is 16. And that should be all that I can pull out, and it looks like it is. Now we just kind of keep going. So step 1 is done. There's no more greatest common factors we can pull out of that set of parentheses. It's not a binomial, so we skipped step 2. Step 3 was trinomials. So I'd recommend, is it a perfect square trinomial? The plus 16 looks promising, but that 5 is not a nice non-decimal number squared. So we're just going to have to go back to saying, all right, I'm going to take this part here, and I'm going to break that trinomial up into 2 binomials. Well, I have a plus and a plus for my signs. I can tell that because this tells me it's either plus plus or minus minus. This tells me it has to be plus plus. And the nice part about taking that 2 out is there's fewer options, that I really have to have a 5x and an x for that first thing. If I had done this with my 10, I could have a 1 and a 10, or I could have a 2 and a 5. So this narrows things down a little bit. All right, so my plus 16, I'm looking at that 16 there. I could have a 1 and a 16. I could have a 2 and an 8, or I could have a 4 and a 4. Well, for those, where could I put those numbers and get that plus 24x? I am going to say, I'm going to start with a 4 and the 4, I think. And kind of what I was thinking is, well, if I put a 16 here, that's going to give me something way bigger than 24. That's like 80. So that's not going to be it. If I put my 8 there, same thing, I have a 40. That's way too big. So I was saying, well, if I put a 4 there, that gives me a plus 20x. And then my other 4 goes there, gives me that last 4 that I need. So outside and inside will give me my plus 24x right there. The first times the first gives me my 5x squared, and then my 16. So now we're done. But let's say we don't know we're done, because sometimes we're not. You have to look at those there and say, all right, I have 2 binomials. Difference of squares? Nope, because of the plus. Difference of squares? Nope, because of the plus. And, well, and also that's not something squared, not something squared. But once you check that out, you can tell for sure you're done. Final answer, those 3 polynomials right there. 1, 2, 3. All right. Number 4. Dun, dun, dun. All right, so this one here, it's a potential for difference of squares, but I'm going to say life is always easier if you do greatest common factor first. So I see my 8 and my 18. I know I can pull out at least a 2. Could I pull out a 4? Not a 4 out of there. I could pull out an 8, but not an 8 there. So it looks like a 2 is going to be what we can pull out. But looking at my variables, x to the 6, so I can pull out an x squared and I can pull out a y squared, because both terms have an x squared and a y squared. So 2x squared y squared. All right, now what's going to be left? So my first thing, 8 divided by 2 will give me 4. X to the 6th divided by x squared is x to the 4th. Y squared over y squared just drops out. So maybe switch to blue a second. So I had 4x to the 4th left there. All right, and I have a minus sign. 18 divided by 2 gives me 9. X squared over x squared, those cancel out. Y squared over y squared, those cancel out. And we can't quite stop yet, but we're getting close because this part here is going to be another difference of squares. We could square something and get this. We could square something and get that. We have a minus sign right there. So I'm going to copy down that part in black, my 2x squared y squared. And then I can take this difference of squares and break that up into 2 binomials. And it'll be a plus b times a minus b if you go back to that general form. So you need to figure out, okay, so now a is going to be what squared gives me that. So it'll be a 2x squared. And I can write that in both of these binomials. So squeeze a 2x squared in there. And now the b is going to be, well, what squared gives me 9? So that'd be a 3 and a 3. All right, so now we're a little bit further, and we just have to make sure we're done. So this we knew we couldn't factor. And this here, it's a binomial, but it's not a minus sign, so it's not a difference of squares. Here we have a minus, but we don't have a nice thing with integers that we could square to get the 2. Same with the 3. So we are officially done. So this section here, some of it is figuring out when you're done, some of it is doing the different steps. With some practice, I think it will be good. Let me know if you have questions. Be glad to help.